Now we will learn about application of inductive effects. There are lots of application of inductive effects. We will learn one by one application. First of all, we will learn about application of inductive effects in deciding the strength of acidic strength. We will learn about in deciding the acidic strength of aliphatic carboxylic acid. Mainly we will focus about the acidic strength of carboxylic acid. So suppose first of all we will learn criteria. Minus I effect proportional to acidic strength means I effect increases, acidic strength increases. Plus I effect proportional to basic strength means plus I effect increases, basic strength increases. From this we can conclude that plus I effect increases, acidic strength increases. As plus I effect increases, acidic strength decreases. Plus I effect increases, acidic strength decreases. In any compound, suppose compounds COH and any group is connected. If this group will be minus I group, if this group will be minus I group, if this group will be minus I group and this minus I group increases, then acidic strength increases. If this group will be plus I group, if this will be group effect plus I group increases, acidic strength decreases. Means if this group will be plus I, then acidic strength will decreases. If this group will be minus I, and as the minus I will increase, acidic strength will. Now you are clear that minus I effect increases, acidic strength increases, plus I effect increases, acidic strength decreases. But plus I effect increases, basic strength increases. Why these are happening? Why minus I effect increase the acidic strength, why plus effect increase the basic strength? We will explain these things now, later. First of all, let we see some examples of plus I effect and minus I effect in acidic strength. As this is a carboxylic acid, carboxylic acid. In all this, all are carboxylic acid, but these groups which are connected are different. Here only this is a formic acid, is a 1 methyl, 2 methyl, 3, 4. Here is a 3 methyl, 4 methyl. Actually, this is a wrong. This is not. Leave this. 3 methyl and 4 methyl. As a methyl is act as like a positive inductive effect. It will provide positive inductive effect. So positive inductive effect increases, acidic strength decreases, as I have already told. So in this way the positive inductive effect increases. Here is a 4 methyl, 3 methyl, 2, 1. In this order positive I effect increases. Positive I effect increases means acidic strength decreases. So acidic strength decreases in this order. So the actual acidic strength will be in this compound's acidic strength will be more than this. This compound acidic strength will be more than this. This compound acidic strength more will be than this. This compound acidic strength will be more than this. Now we will learn why acidic strength is dependent on the inductive effect. How they are related. Acidic strength how are related to positive inductive effect and negative inductive effect. Actually in acid, suppose this is acid C4H9COH. This is acid. If in acid this will leave, for acid will be formed by leaving this as a H plus. As H plus this will leave, then compound form will be COO minus. This will form COO minus. The compound form will be CO minus. CO minus. Here is the not a proper color. Compound form will be CO minus. So this compound will form after losing a proton and hydrogen, and this become a carboxylic ion. This is anion is forming. So as this anion will be stabilizing, this anion stability increases, steric strength increases, because after leaving this H, how this H will leave? In this way leave, this become H plus, this is become minus. So as the stability of this anion increases, acidic strength increases. So minus I effect will draw as much possible electrons, so it will stabilize these compounds, because as the negative charge decreases, stability increases. So electron withdrawing group decrease the electron density, because becoming an anion, it is more electrons. Anion has more electrons, these compounds become anion, so it has a more electron density, so which the compounds which decrease this electron density, which stabilize this compound. So plus I effect, it pushes the electron to this compound. Plus I effect, here it is as a plus I effect. So plus I effect increases the electron density to this compound. It has already more electron density, because it is anion, and plus of I effect increases another some amount of electrons, so it will destabilize this anion. So acidic regarding acidic strength, when compounds get so acid, when there is some factor which stabilizes the anion, as the stability of anion increases, acidic strength increases. So in this order, this I effect increases, acidic strength decreases. Here I have already written plus I effect increases, so acidic strength decreases. Formic acid has no alkyl group, is most acidic among this acid. I have also some example like this. This, for example, which 1, 2, 3, 4, which one is a more acidic? Here, which one is a more acidic? Question is asked about which one is more acidic. Now we can clearly say that this compounds, here is a minus I group, this compounds minus I group, this compound minus I group. This compounds doesn't have any I group, and I group is a distance, is dependent on distance. I effect is dependent on distance. So as the distance increases, I effect decreases. So here is the carboxylic acid. So as much as the nearest chlorine, as much nearest of these compounds, acidic strength will increases. Here chlorine in the first positions 2, 3. Here chlorine in the first and second, chlorine in the second positions. Here chlorine in the third position. So as the distance increases, I effect decreases. So here chlorine is providing minus I effect. So as much increases, I effect increases, acidic strength increases. But here is in the second position, chlorine go in second position, so I effect decreases, so acidic strength also decreases. Here the chlorine come to the third position, so I minus I effect decreases as the distance increases, so acidic strength decreases. So in these 4 compounds there is no any minus I group, so only this compound is there. So all these compounds has a minus I group, so all this compound has a more acidic strength than this 4 compound. But first compound has a more acidic strength than second has a more acidic strength than third. I have already explained that because of I effect are distance dependent, so distance increases, minus I effect decreases, so acidic strength decreases. So first will be higher acidic strength, then second, then third, then fourth. I have also mentioned these things, acidic strength first, second, third, fourth. I have already explained this thing. When we know that I effect increases the acidic strength, but distance dependent effect, but it is a distance dependent effect. So where the minus I group is nearest to COOH carboxylic acid, is exert a strong effect and make acid stronger. This thing I have already explained. Similarly, acidic character of alcohol. We have learned about acidic character of carboxylic acid. Now we will learn about acidic acid of the alcohol. The similar things will apply in the alcohols, any compounds. Here is alcohol, here is alcohol, alcohol and alcohol. All these compounds have alcohol, but all these compounds have a different I group are connected. These three are minus I group, but this one is a plus I group. So plus I group decreases the acidic strength, so this come in the last. This need not to be considered for deciding the acidic strength. This will automatically come in the last, because here plus I effect are applying. All other things are same in the all four cases, but only difference in the I group. So we should check about the I group. Here I group is a plus I group, so it will come in the last in the acidic strength. But three R group are comparable, but in the order of minus I group, I have already show a trend where NO2 has a higher minus I effect than chlorine. So chlorine nitro NO2 has a more minus I effect than the chlorine. So nitro will provide more acidic strength, as I have shown. This provide 3, 2, 1 arrow. In this way we can denote the acidic strength, electron withdrawing group minus I effect. In this way we can denote. So that's why this one is higher acidic strength than this, and then this. The order will be like this. Acidic strength will increase. In this way acidic strength will increase. Now example second, these things are same in all the four compounds. The same things are same, only these things are different. So these groups are plus I effect are providing. So plus I effect increases, acidic strength decreases. Here only CH3, this compound is common, so no need to be bothered about this compound. So these compounds come in the first, because here is CH3 plus I effect are applying, so this will have less acidic strength. Here is 2-methyl is applying, so this is a less acidic strength. Here is 3-methyls are applying, so this is a less acidic strength, because 3-methyl provide more positive I effect, 2-methyl less than 3-methyl positive I effect, and these compounds only 1-methyl has a plus I effect. This all provide plus I effect. This all group providing plus I effect. This also plus I effect. This group also plus I effect. So plus I effect increases, acidic strength decreases. So we need to think about the plus I effect, and in this order the plus I effect increases, so acidic strength decreases. So in this order acidic strength will increase, because here is a less I effect, here is a 1-methyl plus I effect, here is a 2-methyl plus I effect, here 3-methyl plus I effect. Now we will learn more examples. Here these things is common. Here this thing, that much of things is common. Here NO2 is applying, here fluorine is applying, here chlorine is applying, here bromine. So fluorine, chlorine, bromine, fluorine is higher plus minus I effect, NO2 has a higher negative I effect, chlorine, bromine. So order minus I effect increases, acidic strength increases. So in this order the acidic strength will increase. Here is the similar things. This is the same group, same. So fluorine, chlorine, bromine, iodine plus minus I effect increases, acidic strength increases. So fluorine, 3-fluorine has a higher minus I effect than the chlorine, then the bromine, then the iodine. Here is a one mistake is there. In this way this will come. Now this compound, compare the to the water. Phenol is more acidic, minus I effect, but methyl alcohol is a less acidic, plus I effect. Here is a phenol is there, here is a water is there, here CH3 is there. We have to think about plus I effect and negative I effect. Here these compounds will draw electrons towards it. Here is no any compounds to drawing electrons from this. These compounds are similar, alcohol are similar, but this will provide plus I effect, this will provide minus I effect. So it is obvious that minus I effect will have greater acidic strength than this water. It is providing plus I effect, so it will definitely decrease the acidic strength, so it will become in the last. In this way we can decide the acidic strength. So acidic strength, this is the increasing order. this will draw electrons because there is a ring. So by the actually these are in this way. So by the here minus charge is created, here plus charge created, this lone pair become a bond. In this way this will draw electrons, this will act as a like a negative I effect, but only have to think about the negative I effect plus I effect, how they affect the acidic strength. Relative strength of the base, basic nature of NH2. We have learned about the acidic strength of carboxylic acid, alcohol. Now we will learn about the basic strength. Basic strength we will learn about as the plus I effect increases the basic strength. So we will learn about